Welcome to Light and Sound. Lesson number 1 on waves. Lesson 1, part 1 is called Real Life Applications of Waves. Make sure you have your notes downloaded so you can carry out this class with me. Real life applications are called STS, Science, Technology and Society. You don't really have to know that. Basically, you'll see them in your notes as broken line boxes in grey. Now, you don't have to know them in any great detail. You just have to read them. So read them, because the kind of question they'll ask in the exam will be something like, give a real-life application of the Doppler effect. And you will say something like speed traps. There's very few that you have to know in detail. The ones that you have to know in detail, we will get to later. So let's look at some real-life applications. Well, you know about water waves. You drop a stone into a pond and the ripples travel out. They'll travel out and will look something like this. You've got your crests and your troughs. You can also get these giant waves called tsunamis that you know about. So an earthquake will take place into the ocean. These giant waves will travel at a huge speed and they can cause enormous damage. We've also got these things called radio waves. So let's say on the ground, I've got a transmitter that will send out these radio waves, and I have you called the receiver. Our radio waves are electromagnetic waves. They can travel through a vacuum, and they can travel along the ground from the transmitter to the receiver. They're very long wavelengths, so they can leap over mountains. They can also do something else. There's a band of particles high up in the atmosphere called the ionosphere, and it acts like a mirror. Those radio waves can travel up there and down to the receiver. So the receiver can receive the waves in two different ways. So these are used in telecommunications. More about that later. We've also got seismic waves. The seismic waves occur after earthquakes. They travel out and they can cause a huge amount of damage. Let me talk about two particular properties of waves: mechanical waves and electromagnetic waves. Well, first of all, how do I make waves? I make waves with things called oscillators. An oscillator is something that goes back and forth. What's an example of an oscillator? Well, your voice box, my voice box that you're hearing now, or a tuning fork. You hammer a tuning fork onto a hard surface, and what happens? The prong will vibrate back and forth. So the prong is an oscillator. Look at these air molecules here. They're minding their own business. They're nice and calm. And suddenly they are attacked by that oscillator. And that oscillator will crash into that air molecule, cause it to vibrate back and forth. And that vibration will pass down from molecule to molecule. And you'll have the wave traveling out here through the right. That is a mechanical wave. And the reason it's a mechanical wave is because it needs a medium in which to travel. That medium being air. If I cause that tuning fork to vibrate in a vacuum, then you'd hear absolutely nothing. So it needs something in which the wave can travel, some kind of medium. Whereas if you take something like an electromagnetic wave, like light, through which we see, well, the oscillator here would be charged like an electron. You know what electrons are? They orbit around the nuclei of atoms. And when that electron starts vibrating, then you get this wave that travels out. This is called an electromagnetic wave, and it can travel through a vacuum. So mechanical waves need a medium, and electromagnetic waves, they do not need a medium. They can travel through a vacuum. If I look in my notes, Here's some examples of mechanical and electromagnetic waves. So mechanical waves examples are sound waves. We've already talked about that. Water waves we've talked about. And ultrasonic waves, waves that can take pictures of the unborn baby in the womb. And examples of electromagnetic waves are light waves. What I mean by light is visible light like the colors. But we've also got radio waves and X-rays, which are also light that you can't see. The radio waves we've talked about that are used in telecommunications, and X-rays that are used to take pictures of broken bones. Okay, so that's the end of Lesson 1, Part 1.